Yeah, hi. So we will take a look at question number 8. Let us see what is given in the problem. 8 is saying that, so this problem is saying that a train is moving with a velocity of 90 km per hour. It is brought to stop by applying the brakes, which produces a retardation is given. Find the velocity after 10 seconds. So you can say that what is given quantity. Given is it is given that the initial velocity of the train is given. Initial velocity is 90 kilometer per hour. Okay. And what else? It is brought to stop. Okay. It is brought to stop by applying the brakes, which produces a retardation of 0.5. So final velocity is 0 for sure. It is brought to stop, which produces a retardation of, the value of retardation is given. So in the form of acceleration you can write it in the form of negative 0.5 meter per second minus 0.5 meter per second. So what is being asked? Find the velocity after 10 seconds. So in first part, train is moving, right? Let us make a one coach of train, right? It is moving at certain velocity, which is u. It is moving at a velocity of u. After traveling, the brake is applied instantly. It will not stop. Of course, it will travel some distance. Now it is being asked the velocity after 10 seconds. So what do you think, guys? Velocity after 10 seconds will be how much? It will be 90 km per hour, or more than that, or less than that. The final velocity will be less than 90 km per hour. But one thing which we should do here is that I think we should convert this 90 km per hour into meter per second. So let's do one thing. We should convert it to SI unit, because acceleration is given in SI unit. So you can say that you have to multiply 90 by 5 by 18 factor. Okay, so that will give you 25 meter per second, right? So now you have U, you have P, you have A, right? U, V, A, right? So what is that? Find the velocity after 10 seconds. So given is, okay, as part of A it is given, what is the time? 10 seconds. What is velocity? It is asking velocity after 10 seconds. What is the velocity after t equal to 10 seconds? Okay. What is the velocity after t equal to 10 seconds? So we have t, we have u, t, we have t we have, and we are being asked to find out v. So we can use this v at t equal to 10 seconds, right? So we can write it, and u plus at, right? What is the value of the u? The value of u is 25 meter per second, right? We cannot go with kilometer per hour. We should go with SI. 25 meter per second plus, what is the value of the acceleration? Acceleration is minus 0.5. What is time? Time is 10 seconds. So how much is the velocity? 25 minus 5 is equal to 20 meter per second. After 10 seconds, it will retard to a velocity of 20 meter per second, right? Initial velocity was 25 meter per second. Brakes were applied, so after 10 seconds, velocity reduced. Velocity after 10 seconds is 20 meter per second, right? So this is the meaning of retardation. What is the second part it is asking us to calculate. It is asking the time taken by the train to come to rest. So it is again given that. How much time it will take? Given v equal to 0. It is asking time in how much time? Simple. So we have v, we have u, we have a. So again we will use v equal to u plus a, right? So we can say that u plus a t equal to b, right? With the help of that we will try to calculate it. What is the value? What is the value of u? U is 25 plus a is minus 0.5. T is t. V is V is 0. Okay. V is 0 because the train, after how much time train is going to stop? This is what it is asking, right? So can we find out t from here? Yes. It will be how much? 25 divided 0.5 t equal to 0. So t equal to how much? 25 by half. 25 by half. 25 by 0.5. 25 by half will give you 50 seconds. So in 50 seconds, train comes to rest. So brakes were applied. So we were in first part we were asked to find out the velocity of the train after 10 seconds, right? Which we found out 20 meters per second. And then we were in second part we were asked to find out the time in which train finally stops. Train finally stops at 50 seconds, right? Let us jump on to the next problem, please. Okay. So we'll try to solve question number 9. Okay. So what is a car travels a distance of 100 meter with a constant acceleration. A car travels a distance of 100 meter with a constant acceleration is constant, that is given, right? Okay, let us write down what is given. Given is, see, how to make a car. Okay, you should make a car first. Right? Car is must have been traveling with some initial velocity. A car travels a distance of 100 meter with a constant acceleration. Right? So what is given? Given is that car travels 100 meter. It travels 100 meter. Okay? It is stored here, right? So S is given, the value of S is 100 meter, right? With a constant acceleration. It is given that acceleration is constant. Acceleration is constant. That means if acceleration is constant, that means velocity is increasing. Simple. Velocity is increasing. Right or not? Acceleration is constant, that means velocity is increasing. Obviously, that is the meaning of that. The final velocity acquired by the body, the average velocity is given, right? It is also saying that the average velocity is how much? Average velocity is 20 meter per second, right? 20 meter per second, okay? What else is given? Average velocity The final velocity acquired by the car is 25 meter per second. The final velocity acquired by the car is 25 meter per second. Right. Let's see what we can calculate. See, from this acceleration is constant, the velocity is increasing, right? And average velocity is also 20 meter per second. So in this case, the distance which is given here, that is the distance traveled in a fixed direction. So we can write it that this way: V average, right? Would say that the distance covered in a fixed direction, the distance covered in a fixed direction, okay, in a fixed direction, distance covered in a fixed direction upon time, right? So what is the average velocity? 20. What is the distance covered? 100 meter. What is the value of the t? So you can calculate the value of the t is 5 seconds. So you can see, yes, in 5 seconds the car achieved a velocity of final velocity of 25 meters per second, right? So let us see what is being asked. It is being asked that what is find the initial velocity. Find the initial velocity. So we have to find out the being asked. Find the initial. So we have to find out initial velocity. What is initial velocity? U we have to find out, right? So okay. So what we will do here is that we will apply here V equal to U plus AT concept, right? V equal to U plus AT concept. So as per that, what can we write? What is the value of the V? V is 25. That's good. U we don't know. We have to find out. That's good. What is the value of the T? T we just calculated 5 seconds, right? So can we write 5A? Please. Yeah, we can see that. Right? Can we mark it equation 1? Yes. We will use it later. Later part. So and then what is given? You are being asked. You can. We have to find out U. Okay. But there are two unknown variables. So we have to use S equal to UT plus half AT square. What is the value of the S? S is 100 meter. U is, we don't know. T is 5. So we know that it becomes 5. What is the problem? No problem. And T square is 25. So can we write it as 25 by 2? Okay. Right or not? Right? So can we think in a little bit better way? That can we rewrite it as 100 equal to 5u plus, I am saying is 25 by 2 and this is 5u. Okay, fine. So can we write it as 5 by 2 into 5a? Can we write it as 5 into 5? We'll give it 25. 25a by 2. It remains as 25. So I have just split it. I have split this term because so that I can use this value 5a from here. 5a I can use this from here. So what is the value of the 5a from equation 1? From equation 1, we can say the value of 5a is equal to how much? 25 minus u. Right? 25 minus u. Right? So now what we will do? We will use this value here. This one. So we will write here 5u, sir. And then we will say 5 by 2. So, and then 5a, in place of 5, I will write this particular value, right? This particular thing. Okay. So I will write here 25 minus u. Okay. So let us solve this problem. Okay. Can we take the I say that 100 equal to 5u plus 125 by 2. 125 by 2 minus 5 by 2. Any problem? No problem. So now you can go ahead and say that. See here, that 100 is equal to what? 5u minus 5 by 2u, it will give you 5 by 2u, simple, plus 125 by 2, right? So from here, what we can do here is that, from here we can do that 100 is equal to 2, we are taking common, 5u plus 125, cross multiply. So let's do cross multiplication. So what we are doing, okay, we are going to get 5u plus 125, right? Cross multiplication. So this coming 200, right? So out of that, what we are going to get is that 5u is equal to 200 minus 125, that is 75. So we are going to get that u equal to 15 meter per second. So we found out the value of the u equal to 15 meter per second. And now it is asking what is the value of the a. So this part we are done. Just give me a moment, please. So part of that, what we are going to do is we are finding out axis distance, right? Axis distance is what is that? V minus u by t. What is the value of v? We have the value of v as 35, okay? And what is the value of u? U we have just calculated it as 15. And what is the value of t? T we have calculated 5. Okay? So 25 minus 15, 10, 10 by 5, 2. 2 meter per second per second. Yeah?